On this last problem, it says determine the value of C for which IL of t exhibits the fastest smooth response. So fastest smooth response means critically damped. Critically damped means alpha equals omega naught. Now this is parallel. And so for a parallel RLC circuit, now notice when we, if I simplify this a little bit, I can say two 6-ohm resistors in parallel are the same as a 3-ohm resistor, and that's 5 millihenries. And that's C, that's our unknown, and that's our 8 ohms. When we look at what this is going to be once we close the switch, then for the resistance, we would want the Thevenin resistance. And so the Thevenin resistance is what we would get by shorting out the current source. So to find R, we would look at this. Where that's 8 and that's 3. And you can see that the 8 and the 3 are in parallel. So R equivalent is product over sum 24 over 11. Okay, but we know that we want omega naught to equal alpha because they asked us for the fastest smooth response. For a parallel RLC, alpha equals 1 over 2 RC. Omega naught always equals 1 over the square root of LC. So we want 1 over 2 RC to equal 1 over the square root of LC. We're trying to solve for C, so we'll square both sides. Is the table breaking again? Yeah, it just breaks. So we'll square everything. So this is 1 over 4R squared C squared equals 1 over LC. I can cancel I can cancel one of the C's and then multiply both sides by C and multiply both sides by L. And the C cancels with that one, and that L cancels with that one. And I get L over 4R squared equals C. And so now L is 5 millihenries, so that's 0.005 over 4, and we said R was 24 over 11 squared, or this gets us 0.0002626 farads, or 0.2626 millifarads. Okay, so the next thing it asks for is to use the value of C that we found here to find IL of t for t equals 0. So we know that we made it so that it was critically damped. That's how we set it up. It has to be critically damped. So we are using this. Now let's take a look at our circuit. We need IL of 0, IL at infinity, and VL at 0. So at 0 minus, we had a voltage source of 9 volts. We had a 3 ohm resistor. Well, at 0 minus, we'll have a short circuit where the inductor was. We'll have an open circuit where the capacitor was, and we have another resistor over here of 8 ohms. So IL of 0, what's going to happen, notice this, the inductor shorts out that resistor. So V equals IR, 9 equals I times 3, I equals 3 amps. Okay, so now, and so that has to be IL of 0 minus, which also has to be IL of 0. So now let's look at infinity. So actually, did I want to do that?
Wait, wasn't the switch open anyways in the beginning?
This is infinity. I'm sorry. This is infinity.
Yeah, you drew infinity.
Yeah, this is infinity. Yeah, this is infinity. Yeah, so now let's do 0 minus. And you'll see why I was confused for a minute. So at 0 minus, I have three ohms, 9 volts, and an open circuit over on the other side. So at 0 minus, I also have, so then when I got 3, I wasn't thinking about it because I had just done this problem. So IL of 0 equals 3. IL of infinity equals 3. So we have B1 equals IL of 0 minus IL at infinity. So what does B1 equal?
0.
0. That's nice. Okay. Now we also need VL at 0. So VL at 0. Let's take a look at 0. We would have.
You sure it's not BC?
No, it's VL.
Is VL you?
Yep.
Okay.
VL at 0. So we have. This, we know that, oh, well, wait a minute. I think okay, so notice at 0 minus, our capacitor was right here. What is VC of 0 minus? It's in parallel with a short circuit.
0.
So it's 0. Okay, so at VC of 0, at 0,
It'd be 0.
it's still 0. And since it's 0, and this inductor is in parallel with it, VL of 0 also has to be 0 because it's in parallel with the 0 voltage capacitor.
I mean, with the voltage already being 0
Across what?
I mean, with the voltage of the capacitor already being 0, wouldn't the... Oh, that's the voltage of the inductor.
That's the inductor.
I'm thinking...
Yeah. Yep. Okay. And then, so B2 equals 1 over, well, let's just look at B2. VL of 0 is 0. IL of 0 is 3. IL at infinity is 3. So that's 0. So B2 is also 0. So our current, when we fill everything in, Well, it's not quite, because it's 0 plus IL at infinity, which is 3.
Third.